Hello students, welcome to my YouTube channel Fun with Chem. Today I'm going to discuss Edexcel June 2025 Unit 5 MCQs. Okay, so first question is about electrode potential or electrode equilibria. So before starting this children, we need to know the E0 values. For that you need to use the data booklet. I'll write down the E0 values they have given in all four reactions, and the E0 values are given as reduction potentials. So I'll write all the reactions as reduction reaction. Cu2 plus with E, Pu plus. Then we have Fe3 plus with E, Fe2 plus, zinc 2 plus with 2E giving zinc. So the E0 value for this is 0.8 and this is minus 0.26. For copper, it's plus 0.15. Then for iron, 3 plus to 2 plus, it's plus 0.77. For zinc, it's minus 0.76. Now we are going to find the E0 cell for each reaction. We know E0 cell is given by E right hand minus E left hand. So when I'm using that equation, I will change it for E reduction minus E oxidation. In the reaction, we have to find which one is undergoing oxidation, which one is undergoing reduction. So we can see silver undergoes oxidation, vanadium undergoes reduction. So the reduction value is minus 0.26, oxidation value is minus 0.8, because minus and plus it becomes minus. So the overall E0 value will be minus or negative. When you have a negative E0 cell, the reaction is not feasible. For a reaction to become feasible, E0 value should be positive. Then I'll apply the same equation for the second reaction. Here we can see vanadium undergoes reduction, copper undergoes oxidation. So reduction 1 is minus 0.26, copper is minus 0.15. Here also you can see the overall answer has a negative value. So that is also not feasible. Then we'll see the third one. E cell, E0 cell, E reduction minus E oxidation. Here oxidized one is iron, reduced one is vanadium. So iron is 0.77. Again, you can see we are getting a negative value to indicate that third reaction is also not feasible. So we have only one option to take B as the answer. So we'll see whether it has a positive value. In this, we can see vanadium is undergoing reduction, zinc undergoes oxidation, minus 0.76. So you can see it has a higher positive value. So the final answer will have a positive E0 value. Therefore, the correct answer for the first question is D, as it has a positive E0 value. Then children, here we need to find the color change, right? First, we should know what is in the burette and what is in the conical flask. From this, mean titer for potassium manganate is 18.95. And also when they say potassium manganate is titrated against, means potassium manganate is in the burette. And iron 2 plus is in the conical flask. So normally iron 2 plus is green. So in this, it has a very low concentration. So normally when we are doing the practical, because this is one of the 4 practicals in chemistry, we don't see that green solution. We can see it as a very pale green solution. So the correct answer is this. And I will add some more for this. We don't use an indicator for this titration because permanganate is a self-indicator. Therefore, once all Fe2 plus has oxidized to Fe3 plus, the color change will be from pale green to pale pink, because when you add at the end point, when you add 1 drop of permanganate, the whole solution will become pale pink after the reaction, right? So the correct answer is pale green to pale pink. Then we need to find the concentration of Fe2 plus ions in the solution. So children, here they have given the concentration and the volume of permanganate. So we can easily apply C equals to N over V to find the moles of permanganate. So I put 1000 here as they gave the volume in cubic centimeters, but the concentration is given in cubic decimeters. So you need to do the conversion. Then moles of potassium permanganate is equal to, in 1000 it's 0.05. Then you have to find how much is in 18.95. 0.05 divided by 1000 into 18.95, you get it as 9.475 into 10 to the power minus 4. That is the moles of permanganate. Then we need to find the moles of Fe2 plus. For that, we need to get the stoichiometric ratio between iron and permanganate. As you can see, it's 1 to 5. To find the moles of Fe2 plus, we need to multiply this by 5. Then you get the answer as 4.7375 into 10 to the power minus 3. Then come to Fe2 plus and apply this equation. You know the moles of Fe2 plus, you know the volume of Fe2 plus, you have to find the concentration only. Divide by 25 into 1000. Then you get the answer as 0.189 moles per cubic decimeter. So we'll check whether it's there. Okay, so we have these answers. So I can take 0.89 as equal to 0.19 moles per cubic decimeter. So I can write it as 1.9 into 10 power minus 1. So my answer is A. Even though it's an MCQ, there's a lot of working in that, right? Then we'll see the next one. What is the percentage error in a single titer of 18.91? So percentage uncertainty is given by uncertainty divided by the value into how many times we are using the apparatus into 100%. So uncertainty they have given as plus or minus 0.5. Value is 18.95. We use the burette twice to take the initial and the final reading and into 100. So you get the answer as 0.05 divided by 18.95, 5.27, which is closer to plus or minus 0.53. Then we'll go to the next one. Which row shows the correct changes in oxidation state? So children, we know, okay, if I go back to the reaction, in MnO4 minus, if I consider the oxidation number of Mn as X, minus 2 into 4 is equal to minus 1. Minus 8 is equal to minus 1. Here X is plus 7. Plus 7 becomes plus 2 for manganese. For iron, it's 2 plus becoming 3 plus. So it's very easy. For manganese, 6 to 2, 7 to 2. We have two answers. And iron, 2 to 3. The correct answer is D. Which reaction occurs at the electrode in a hydrogen-oxygen fuel cell? So that is direct theory, children. So remember that overall reaction at an electrode in a hydrogen oxygen vessel at an electrode. So that means it should be a half reaction. So we can easily omit A, because if it's happening at an electrode, it should have electrons. So I omitted A because it's a overall reaction. So in others, so I can omit C as well. So I'm left with two options, B and D. Out of that, the correct answer is B, because it's direct theory. It's given in your student book. What is the electronic configuration of zinc? So we know atomic number of zinc is 30. I can write 1s2, 2s2, 2p6, 3s2, 3p6, 3d10 and 4s2. Then when it's forming zinc 2 plus, we are always removing the outer electron. So this is the argon electronic configuration, and then you get it as argon and 3d10. Answer is A. What is the color of the aqueous solution of V2 plus? That is also direct theory in topic 17. It's purple. C. Which is incorrect for water, OH and ammonia? All can act as bidentate ligand. Bidentate ligand means, children, it should be able to form two dative covalent bonds with the central metal ion. But we know these three are monodentate ligands, so it's wrong. All can act as electron pair donors. That is correct. In water, you have a lone pair on oxygen. In hydroxide also you have a lone pair. Ammonia also you have a lone pair. All can form dative covalent bonds. That is also correct. All can take part in. That is also correct. So the wrong one. So they have asked for the incorrect one. So they are not acting as bidentate, but they act as monodentate ligand. Which product forms when butyl amine reacts with ethanol chloride? So butyl amine means CH3, CH2, CH2, 4. Butyl means 4, amine means NH2. Ethanol chloride is ClCO, So to show how the reaction is happening, I will draw the displayed formula only for the amine group. Then we know HCl will leave. Then you get CH3, CH2, 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 NH, CO, CH3. Which products form when an HCl is also removed? The name of this is known as N-butyl ethanamide. Ethanamide means CH3, CONH2. So we don't see any product like that. Butanamide means CH3, CH2, CH2, CONH2. Product is not butanamide also. N-butyl ethanamide and N-ethyl butanamide. So what are the difference? N-ethyl means nitrogen should connected to a ethyl group. Butanamide means amide group should have 4 carbons, something like that. So that is also not the correct answer. So the correct answer is N-butyl, because N is connected to 4 carbons. N-butyl ethanamide. So C is the correct answer. Which are the reagents and conditions for the reaction shown? So you can see the only change is NO2 becoming NH2. For that, we need tin and concentrated HCl and reflux. That is direct theory. Then the ninth one, at what pH would the amino acid phenylalanine have the structure shown? So you can see, children, if it's an amino acid, you have to have a carboxylic acid and the NH amine end. So here amine is protonated and carboxylic acid is deprotonated. So this should be the pH when it is forming a sweeter ion. So you have to know the pH of phenylamine when it is forming the sweeter ion. That is also direct theory, which is pH 6. There's a table in that they have already given. You have to know the structures of the 4 amino acids, glycine, alanine, right? There are 4 amino acids, glutamic acid. So then you have to know the pH at the isoelectric point. Then we'll see the next one. Okay, suppose if you don't know that, then if it's pH 2, it's too acidic. Then only the amine group should be protonated. pH 10 and pH 14, they are too basic. Then only carboxylic acid should be deprotonated. So the one that is closer to pH 7 is pH 6. So you can find the answer like that also. Which is the repeating unit of the polymer formed from the monomers shown. Okay, so children, to explain that, I will have to draw them separately. Okay, there's no space here. Okay, so COOH and NH 1, 2, 3. 1, 2, 3. So 1, 2, 3 and NH. Here we have COOH. When this is undergoing condensation polymerization by the removal of water molecule. So we know OH should remove from the carboxylic end, hydrogen should remove from the amine end. So the continuation bond will start from here, then an amide bond will form between the carboxylic acid and diamine. So this should be the repeat unit. So you can see in the first one, this part is there, so but N is missing. Therefore, that is wrong. In the B part, you have this group, so B is also wrong. C, it looks correct. We'll see whether everything is there, right? We have the carbonyl group, benzene, amide. Okay, so C is the correct answer. Then this, what is the name of the functional group that is replaced in step A? So what is this? What do you call that? Nitride. CN is known as a nitride. What type of reaction mechanism is taking place in step B? In step B, we know a ketone becomes a hydroxy nitride. That is, you have to know the reactions of ketones and aldehydes. The reaction of ketones and aldehydes is nucleophilic addition, right? So the correct answer is C. I have explained that in 2025 Unit 4 paper discussion, all the reaction types from alkanes until carboxylic acid. So you have to identify the functional group and then only you can easily identify the type of reaction. What are the reagents used in step B? In step B, to convert a ketone to a hydroxynitrile, we need to add KCN and HCN. So the correct answer will be, those are direct theory, children. You all have to study those reactions. So the correct answer is B. What is the percentage of carbon by mass in the final product? Final product is this. So we have to find the number of carbon atoms 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 12 into 10, it's 120. They have already given the molar mass of the final product, 120 into 100. So you get it as 72.7%. A substitute benzene compound has the general formula CnH2n minus 6. When completely combusted, 0.025 compound produces 11 gram of carbon dioxide, which could be the molar mass of compound. Okay, so first, as they have given the moles of mass of carbon dioxide, I can easily find the number of moles of carbon dioxide. 11 divided by 44. 44 is the molar mass of carbon dioxide. So 11 divided by 44, that means 0.25 moles. So they have given the moles of the compound. So we'll take it as X2 carbon dioxide, 0.025 to 0.25. Then if you divide by the smallest decimal number, when you divide by 0.025, you get it as 1 to 10. That is the ratio. Right? So then we found the ratio between, that means X plus O2 gives carbon dioxide and water. 1 mole will give 10 moles of carbon dioxide. So we know the moles of, so we found 0.025 as the moles of the compound. So we need to find, okay, so we know that there are 10 moles of carbon dioxide to indicate that there are 10 carbon atoms. Then we have to CnH2n minus 6. We'll take it as 12 into 10 plus 2 into 10 minus 6, 120 plus 20 minus 6. So you can easily find the answer. 120 plus 20 minus 6. You get it as 134. So if I explain again, I found the number of moles of carbon dioxide, 11 divided by 44, 0.25, right? 11 divided by 44, yes. 0.25. Then I got the ratio between the compound and carbon dioxide, because the number of moles they have given. Then I should divide it by the smallest decimal number to get the stoichiometric ratio between the two, 1 to 10. So if I write the equation, CO2 H2O, this for 1, you have 10 carbon dioxide. So the only place you can have carbon is carbon dioxide. If you want to put 10 in front of carbon dioxide, that means you have 10 carbons in the compound. They have already given the general formula. Then we need to substitute. Carbon is 12 into 10 plus 2 into 10 minus 6, because hydrogen is 1. So then only you get it as 134. This question is about branched alkanes. How many peaks are there in the carbon-13 NMR spectrum of 2,2-dimethyl propane? Propane means I have 3 carbons. 2,2-dimethyl means I have 2 methyl groups. So we can see all 4 are connected to 1 carbon. So all these 4 will have 1 peak, and with the other carbon peak, you have only two peaks in the compound because all are connected to the same carbon. So all of them will have the same chemical environment. Then we'll see the next one. 4 students sketched the high resolution proton NMR spectrum of 2,3-dimethyl butane. So always children, you have to draw the compound and see. Butane means always start from the number of carbons as in the final name. Butane means 4 carbons. 2,3-dimethyl means you have a methyl group on the second carbon and the third carbon. Right? So first we have to identify how many environments are there. We can see that 1, 2, they should have 2 protons also, and it's a symmetrical structure. So both of them will have one chemical environment. These two will have another chemical environment. So there should be only 2 peaks. So A is anyway wrong. This has 4 peaks, it's wrong. So out of that, we have to find which one is correct. So if I take A, that is for all the methyl groups. And for A, if I apply N plus 1, the adjacent carbon has only one hydrogen. 1 plus 1, it's a doublet. So the big peak should be a doublet. So we can see only a doublet in this. Then if I take B as the other one, and if I apply N plus 1, it has 6. Because the adjacent carbons have 6 protons, 6 plus 1, it's a heptad. So you can see 1, 2, 3, 4, 5, 6, 7. So this B is the correct answer. N is for the number of hydrogens in the adjacent carbon. If you want to find the splitting pattern of, now if I take one particular one, if you want, you can see that there are 2 protons. If you want to find the splitting patterns of A, when you apply N plus 1, the adjacent carbon has only one hydrogen. So 1 plus 1, it's a doublet. If you want to find the splitting pattern of B, N plus 1, 3 plus 3, 6 plus 1, 7, it's a heptad. Okay, so that's all children. I want to discuss with you all. Like and subscribe my channel for more paper discussion videos. Thank you.